Alright, this is a video going over the solutions for the Unit 2 sample test. Just a little bit of a heads up, might be kind of a like a fast-tracked version of the explanations, maybe just hitting like the big ideas and not necessarily all the little separate baby steps. So hopefully, and then the work can hopefully speak for itself. If there's any questions, obviously you can feel free to ask in person or through email. But number one, and I think for the first couple or so, the directions are find the general solution. So we're going to, essentially integrate both sides. Remember, technically, we would need to move the dx to the other side first, but we're essentially integrating to go from dy dx to this, what we're trying to solve for here in the solution, y equals. And if it's going to be a general solution, there's going to be the plus c in the answer that we are not going to be able to actually solve for to get a particular solution. So how do we integrate something like this? Well, again, long story short, like I mentioned, long story short is u substitution. So what you need to let u equals is 2x, and then you are essentially going to be filling in, like, okay, so for dx, we're going to be filling in what? This. So this is what's getting plugged in here, and then the cosine is going to cancel conveniently, like this cosine and this cosine. So we're left with integrating 3u squared, which gets you to this. You plug back in for u, and that's it. So u substitution. This one, you're just going to integrate these two terms. To integrate this one, you're going to want to think of it as x to the negative 2 power. And I mean, I guess you could think of this one as x to the negative 1, but this rewrite's not really going to help us. You just got to remember that when you're integrating 1 over x, that's the natural log of x, or the natural log of the absolute value of x. So we're integrating, we're just looking for a general solution, so you just have a plus c in the answer. And then if you wanted to have a 1 over x, so you have like the negative, and then this could just be written as like 1 over x. That's fine, and maybe even a little bit better. Then in these next couple, we're doing the particular solution, where they give you an initial value, which means you then, you integrate and you get your plus c, but then you figure out what c equals. So how do we integrate that to go from dy dx to just y? We're going to do u substitution again. So we're going to let u equal the x squared, and then, when we plug in du over 2x for the dx, this x is going to cancel nicely with this x, but there's still going to be a divided by 2, so we have like a 1/2 that kind of, appears. And then you're just integrating e to the u, which is just e to the u. Plug back in for u. And then you can go about figuring out what c would equal by plugging in 0 for x and 3 over 2 for y, getting your c equals 1. And then so here's your final answer. Number 4, we're just going to be integrating term by term. So we get 4x to the 4th over 4 minus 6x cubed over 3 plus 6 over 2 minus x plus c. Looks like I cleaned this up a little bit before plugging in my -1 and my 2 and getting c equals -3. So then you write your final answer with, with your c value now saying just minus 3 for the particular solution. Number 5, construct the slope field. So again, every one of these points, so for example, 0, 0, the coordinates right here are 0, 0. That literally means x equals 0 and y equals 0. So when you plug those in, you get an overall dy dx, which is slope of 0. Over here, for example, like at this point, it's 1 comma 2. So that would be 1 minus 2 times 2, which you get a slope, a dy dx of negative 3. So there's that little slope and all the other ones, and yeah, it's nice to label these. Like I'm a fan of labeling what these slopes are. Remember, negative slopes are downhill, positive slopes are uphill, and 3 is, for example, 3 would be much steeper than 1 over 3, because this is like 3 over 1. Getting back into some algebra 1 or even pre-algebra with that comment. So this one here, likewise, I guess all you really care about, like all these dots, all these points, I guess you really just care about what the x value is, because that's what's going to determine the slope. So all of these have an x value of negative 1, all of these have an x value of 0, and all of these have an x value of 1. So there we go. Number 7, so this is Euler's method. I guess for the exam, remember, you do have to be able to come up with, these answers for the first 3 rows, and then you would use your calculator, whatever the program in your calculator that we put in there will give you just the final answer. But remember, the delta y, remember, this does not mean your new y. It means your change in y. So for example, we started off with y equals 1, and then when we get a delta y of negative 0.2, that is the change in y. So the next y value is 0.8. The only other thing I would remind you of here is to calculate delta y. This is something you have to be aware of for the test that you do. So delta y is equal to dy dx times delta x. Once again, dy dx times delta x. Your delta x is right here. Your dy dx is whatever you get, for whatever your x and y coordinates are at the time. You plug those into like x minus 2y, and that's your dy dx part. Then this is just like another one where you end up getting these numbers. Let's see here. So this would be where we really have to go the extra mile to separate the variables. So again, as we move the dx over here with the 2x, we have to multiply the y over here and like move the y over here with the dy. And then we're like integrating both sides. So remember, we integrate y with respect to y, we get y squared over 2. And technically, right, we mentioned this in class if you were there, technically there's like a plus c constant over here on the left side too. But when it comes down to it, like whatever this constant would be, or the plus c constant, can kind of combine over here on the other side with this constant and just be like one final constant. And these are initial value problems, which means we're going to now solve for c. And now look, I don't know what's really best here. If I had like all these answers, I'm not going to be too strict on what your final answer looks like, here in 2023-2024 school year. I might say this one might be the best because it's in the form of like a hyperbola, or not an ellipse, right? I don't think an ellipse. Like maybe a hyperbola graph. It's kind of like it's like, there's circles, there's ellipses, there's parabolas. So I think this looks like standard form of one of those. They're called conic section shapes or graphs. But this one's fine with the plus or minus, like, solving for y. But again, all these are probably fine. Speaking of fine, like this final answer, we would just say it's fine. This one may be a little bit better. And then this one might be the bestest answer, where you actually solve all the way USA for y. It's y equals. So using a little bit of like algebra 1 skills, with like properties of exponents, when do exponents add together? When you have like this. So then you separate the variables, and then when did I integrate? Like here. So I integrated here, I do believe. That's right. So you integrate both sides, and technically integrating the left side here is U substitution. Technically, I did not write out the steps, but technically to get this is, if you wanted to write out all the baby steps, it's technically U substitution. But, this is, yeah, I don't know. If there's any questions, ask in class. Then we move on to the exponential growth and decay, and the restricted growth, and the logistic growth problems. And so this one is talking about half-life. On the test, you need to just know that when they're talking about half-life, that's the exponential growth and decay stuff. So this is the kind of formula that you would use from like your formula sheet or whatever. And in this problem, technically you first have to get K for like this half-life. Heck, you might actually just know by heart what our K value is for the half-life of carbon, like carbon dating. But that's if you're using exactly 5,700 years for the half-life. This is the K value. So technically you got to get the K value first. Then you can plug in the numbers where, okay, so how long would it take for you to end up with like 44.5% left over? So you do this little thing, and you put your K there, and you solve for T, natural log of both sides, all this stuff. Again, not just kind of given just the bigger, bullet points here, which would be, again, first you technically need K by doing the whole, like, half-life, half of it's left over for 5,700, years, right? So first you would get K, then you would use that K value along with, when would it be this much left? Number 12, suppose a nasty rumor is spreading through Fort LaBeouf High School at a rate proportion. Okay, just saying, when you see keywords like that, that's what leads you to, the proper formula, okay? And this one, I believe, it matters that the rumors are growing, right? And so you have to use this particular formula. And anyway, just remember, these are the types of problems where you first have to, figure out how you can plug in 0 for T, right? Remember, first step is figuring out little c. We got to figure out little c, and we do that by figuring out a way to get 0. Like we call something T equals 0. It looks like here we're calling 4 days ago time equals 0. So 4 days ago I'm calling t equals 0. And that means as of today, there are 40. So today I'm calling day number 4. Okay, once you have C, now you can plug that in for C. And, so today is technically now in our problem t equals 4. And that allows us to get K. So if you can't see this on the screen, that says 3,000. And now that you have your little c and your k, which, well, I don't know if I was being lazy or just trying to keep things nice and tidy. But remember, this needs to go in for k, and this negative would actually cancel with that negative. But, so what? 2 days from today would now be, day 6, or t equals 6. So again, this k value, negative and all, with the negative sign, goes in for k, and it all just crunches together to get that. What is the half-life of plutonium? So now, this was trying to catch you. If 75% decays after 48,200 years, that means 25% is left. Remember, what goes here is what's left over. So you get your K value, and then that allows you to solve for T, for like a half-life. When will you have, half of it left over? So that turns out to be 24,100 years. Maybe exactly. But, all right. So first you do this to get our K value. Then we can answer that question. After 100,000 years, how much will be left of a plutonium-239 sample that was originally 500 grams? So we plug the 500 in there. And then we have like our K value and our T value, and just let your calculator tell you that 28.176. I assume that's an approximation. Number 14. A hard-boiled egg at 96 degrees Celsius is put in a pan under running 18 degrees Celsius water to cool. After 5 minutes, the egg's temperature is found to be 40 degrees Celsius. How long will it take the egg to reach 20 degrees Celsius? I don't know if I mentioned something yet, but I think something you're going to have to know with these restricted growth formulas and logistic growth formulas is that your capital A part is like that fixed number. So here, the fixed number was that there is 750 total students. Like that number is not changing, the total. It's like the fixed number. Here, that fixed number would be the temperature of the water. Like the egg's temperature is changing. The temperature of the water is fixed. So that's going to be, and you know what? Maybe I guess you got to remember that, like Newton's law of cooling is restricted growth. So be prepared to just know that if something's heating up or cooling down, that's restricted growth. That's like Newton's law of cooling kind of thing. And let's see. So once again, when you have a little c and a k value, like these constants, you have to find a way to like finagle a way to plug in 0 for t, which it's not difficult here because time equals 0 is the start. We originally have a temperature of 96 degrees for the egg, so at time equals 0, 96 degrees. Remember, capital A, that's the fixed number, and this allows us to figure out little c. Then we move on to this next, moment, where we have like some more information, where at the 5-minute mark, the temperature is 40 degrees. So that means you can plug in 5 for T, and now we know little c. So we use it, and it's 40 degrees now, and then this allows us to figure out K, which then, once we finally know little c and K, now we can finally answer the question, how long will it take for the egg to reach 20 degrees? So you plug all this stuff in. Once again, remember, there's a negative built into the formula. I have a negative with my K value, and those are just going to cancel. So no negatives left over here. Negative, negative. And you solve for T, all those steps that it takes to solve for T. What was the temperature of the egg after 3 minutes? Well, you're just going to plug in for K, and for C, and for big A, and plug in 3 for T, if I didn't already say that. And boom, bam. And there we go. That's just at least the minimum amount of run through for your test for Unit 2.